Alrighty, guys, so we're going to continue on. So, Friday we talked about the tangent ratio, and today we're going to talk about his friends, sine and cosine. Um, the setup for the notes is going to be kind of similar, so we're going to define what sine and cosine are, and then we'll write those ratios, and then we'll use them to find the missing side and the missing angle. Okay? I'm This is a little bit longer, so I'll go ahead and warn you up front. It might be a little bit longer. Um, but if you know what you're doing, you should be fine. But anyway, just be warned, this could be a little bit longer. All right, so we have a triangle here, just like last time. I'm going to label the angles A, B, and C, and then the sides little a, little b, little c. Excuse me. Okay, so we define sine of an angle. It is the opposite side, so it kind of starts out like tangent, but it's over the hypotenuse. Okay? So we can remember it as so, or sine is the opposite over the hypotenuse. You can think of it that way. Cosine, which I like to call sine's cousin, cosine of our angle is going to be the adjacent side over the hypotenuse. So we can remember it as ca, or C is A over H. And I say this specifically because usually in a class you're taught all three at once. You're taught sine, cosine, and tangent. And so off to the side here, I'm going to add this so you can see it. To remember it, we'll use this phrase, SOHCAHTOA. So it stands for sine, which is opposite over hypotenuse. Ca is cosine, which is adjacent over hypotenuse. This is what we're learning today. Tangent would be the TOA, and we learned that on Friday, that tangent is opposite over adjacent. Or as I was taught, some old hag caught another hag tripping on acid. Or instead of, for H, you could use hippie. So some old hippie caught another hippie tripping on acid. That's a fun way to remember it. But you have to remember that what the O, A, and H stand for. Okay. So just some useful tidbits there. Okay, so now we're going to define each of these angles, or ratios, I'm sorry, not angles, ratios. So sine of angle A, so we look from angle A. Sine is the opposite side first. So we go from A, we go across the triangle to the opposite side. That's little a. So little a over. Now which one's the hypotenuse? Remember, the hypotenuse is across from 90. So if you go to 90 and go across, that would be little c. So that would be the ratio. And if we abbreviate like we did with tangent, we would actually write just SIN A equals A over C. Okay, now I'm a stickler here. If you're reading this off to me, like if we were in class and I asked you to read this off to me, you would not say sin A. That is sine of angle A equals A over C. Okay, do not say sin. You still say the whole word, sine. We're just abbreviating when we use it. All right, cosine of angle A you go back to A, but then you start with the adjacent side. So the adjacent side would be this one straight down from it. So that would be little b over the hypotenuse C. We abbreviate cosine as cos of angle A equals B over C. So we don't say cos A. That sounds ignorant. Don't say cos A. Cosine of angle A equals B over C. Okay? Now we're going to transfer to angle B. So sine of B, we start with opposite, so we go all the way across. That would be B over the hypotenuse C. We abbreviate sine of B equals B over C. And yes, there's a reason that these two are the exact same. It has to do with how sine and cosine are related, but we won't go into that right now. Cosine of B is you start with the adjacent first, so that would be little a over the hypotenuse C. And abbreviate cosine of B equals A over C. Okay, so that's how sine and cosine are. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Let's come down here and look at writing ratios. So we want the sine for angle Z. So every time you're asked to write a ratio, you're going to abbreviate the trig function. So you'll write the abbreviation for sine is just SIN. And then we're talking about angle Z. So let's look at Z. Start with the opposite side. Who's across from Z? That would be the 40 over. Now who's the hypotenuse? That would be 41. So there's your ratio. 40 over 41 is your ratio. That does not reduce, and so we stop there. If it did reduce, I want you to reduce it. Same thing, sine for x. So we say sine of x equals, look across for the opposite, so that's 20 over the hypotenuse is 29. And that doesn't reduce either, so we just leave it alone. All right. Now we're going to write cosines. So the cosine ratio for angle C, so I'm going to circle C because that's what I'm looking at. You abbreviate cosine as COS, and you can't see that, I apologize. Cosine of angle C equals, now cosine is adjacent over hypotenuse. So what you could do is, you know the hypotenuse is 39, so you could start there. And then between 36 and 15, which one is adjacent next to it? So that would be the 36. And that ratio reduces, so I need you to reduce it. That's going to reduce to 12 over 13. Okay? Cosine for angle C again, but it's a little bit different. So we say cosine of C equals, you could start with the hypotenuse, which is 34. Now, which one be adjacent? That would be the 16. That's going to reduce to 8 over 17. Okay, now we're going to find missing sides. So it's similar to what we did with tangent. But this time you have to first figure out if you're using sine or cosine first. Okay? And we'll have an activity tomorrow that's kind of a review of all three trigs put together. And on each problem, you'll have to figure out if it's sine, cosine, or tangent. And you do that by looking at what they gave you in the triangle. Now, let me explain what I'm talking about there. So, we know we're going to use this angle 40, so I'm going to circle it. Look at what they gave you. Okay? From the 40, I know that I have the hypotenuse, and I need to know if I have the adjacent or the opposite. Well, opposite's always across from the 40, so go through the triangle and look across. There's nothing there. This is the adjacent side. So that tells me I'm using cosine. Okay, you've got to tell yourself every time which one you're using. Otherwise, you're going to set up the wrong one and you'll get the wrong answer. Okay, so we abbreviate cosine of 40 equals, and then we set up a ratio. The adjacent over hypotenuse, so x over 17. And just now the actual work itself is just like what we did with tangent on Friday. This x is on top, it's going to come down by itself, and then 17 will be multiplied with the cosine. Kind of like a cross multiplication situation. Right? So we will type 17 cosine 40. I forgot to tell you, but make sure that you go to mode and that you're in degree mode. See, mine is in degree. You need to be in degree mode. Anyway, so we will round that number, round it to the 10th. That's actually going to round to just 13. All right. I'm trying to do my calculator here where you can see it. Okay. All right. So same idea. I'm going to look from 36. Remember, we don't use 90. Looking at what they gave me, I know that 19 is the hypotenuse because it's across from 90. This side is across from 36, so this is the opposite side. And so this is a sine problem. So we'll abbreviate sine of 36 equals the opposite side x over my hypotenuse of 19. And just like over here, this top x will come down, and then we'll multiply 19 times sine 36. So 19 sine 36. And if we round that, we will get 11.2. Okay? Again, use the angle that's not 90. Look at what you're given. This side labeled 15 is across from 53, so this is the opposite side. The x now is the hypotenuse. So remember, let me show you. So this is a sine problem. And so we will say sine of 53 equals the opposite over the hypotenuse. Now remember, when x is on the top in all these problems, even back on the tangents, you just had to multiply the bottom times cosine. What we do here is we'll bring the 15 on top down equals x multiplied by sine 53. Now I need to know what the x is, so I'm going to divide the sine 53 away and divide the 15 by it. Now, to save myself room, I just know that you have to type this part in now. On this side, you just have x. So this sine stuff's gone. We're just left with x. You type this in the calculator. You can type that two ways. You can use alpha y and type it in as a big fraction. So 15 over sine 53. Or you can actually do old school division. So 15 divide sine 53. And you get the same thing. So rounding that to the 10th, that would be 18.8. And then the last one about a side, we use angle 33. 12 is the adjacent because it's next to it. X is the hypotenuse. And so we're going to say this is a cosine problem. So cosine of 33 equals 12 over my hypotenuse of x. This top always comes down. X times cosine 33. Now we'll divide cosine. And then you'll type this in, 12 divided by cosine 33. And it's about 14.3. 14, sorry, that's hard to see. Okay, that's a missing side. Now we're going to be missing angles. So a couple of things here. Remember on Friday when we did this, we had to use what was called inverse tangent. It was written like tangent with a little -1 on it. So see above these signs, there's sine inverse and cosine inverse. That's what we're going to use. So we will have to use inverse sine or cosine inverse. And to label your angle, guys, you could use a capital letter for a variable because it's an angle. So you could call this x, you could call it a, you could call it whatever you want. Okay. I like to use this Greek letter theta for t. It usually stands for angle, so that's what I'm going to do. So all of mine are going to be labeled theta. Okay, sorry, twisting my camera around. I still don't like that angle. There we go. Okay, so referencing from this, we have to figure out if it's sine or cosine first. So what are we given? We know 38 is going to be the hypotenuse because it's across from 90. And 36 is across from my theta. So this is the opposite side. So this is a sine problem. So we'll say sine theta equals opposite over adjacent. Yes, I know 36 over 38 will reduce, but I don't care, or we don't need to do it. Right, now remember, we're trying to get the theta, the angle measure. It's caught in here with the sine. You can kind of think about it as being parentheses around it. Sine is in the way. So to get rid of sine, we use inverse. This is how we write it. So you drop the sine on this side, and on the other side, you have to put your sine inverse, and then your fraction. So remember how to type that in. They're written in blue, so we hit the blue key and then hit sine. Then you can type in 36 divided 38 like that. Or you can use alpha y equals and type in the fraction that way. That's usually what I do. But you get the same thing either way. Okay, we were told to round to the nearest degree. That means nearest whole. So rounding this answer is going to be about 71 degrees. Okay, same concept as when we did with tangent, except now it's the inverse sine. Okay, from theta, 45 is the hypotenuse, 34 is now the adjacent because it's next to it. So this is a cosine problem. So cosine of theta equals adjacent 34 over the hypotenuse of 45. And then you type that in the calculator, you'll get about 41 degrees. Okay, last two. 15 is opposite, 19 is hypotenuse. So this is sine again. So sine theta equals opposite over hypotenuse. So then the angle is going to be inverse sine 15 over 19. So theta is going to be about, you type that in, it's about 52 degrees. Now I'm not showing on the calculator, but remember to get this, you have to hit the blue key and then hit either sine, cosine, or tangent, whichever one it is. All right, last one, I'll just tell you it's a cosine problem. 11 is adjacent, this is hypotenuse. So cosine of our angle equals 11 over 12. So then theta equals inverse cosine of 11 over 12. This one's kind of funny because it's a whole number. It's actually 60 degrees flat. There are some values when you do this for sine and cosine that you will get nice, pretty answers. Tangent, you can get them with tangent. It's not as common. But just don't be scared if you get a nice, pretty answer. Sometimes that'll happen. Otherwise, you just round. Okay, that's sine and cosine. So you'll have a homework assignment, and you'll have to determine, especially on when you're finding a missing side or a missing angle, you have to determine if it's sine or cosine first, and that will help you set it up. So make sure you watch the video, complete your homework. As always, if you need help, let me know.